uh, pre-processing, and they are based on pre-processing. The practicals are based on pre-processing and algorithms for data mining techniques, okay, which will come in the subsequent chapters, right? Let me know when my screen is visible to you. Any problem in the last class? Okay, so I'll continue from where we left off. I'll just take a minute to review first what we were talking about. So last time we had started talking about what is KDD, okay? And we had formally defined KDD, and we had said that data mining is actually just one of the steps in KDD. Although it is a very significant step, but it is important to realize that data mining is a part and parcel of a bigger process, okay, and it cannot work in isolation. Why this idea to talk about KDD here is that data mining cannot work in isolation, okay. So one of the examples that I gave you that day, of why we need to, perform pre-processing and post-processing, steps before and after data mining respectively, were for pre-processing. We had, laid down the motivation that the data in the real world is very dirty. Okay. Now, why do I say that the data in the real world is dirty? See, we had said that the data although the data has been collected, we had started collecting the data since 1960s, but it was not collected with the perspective of being mined. It was being collected with just the perspective of being collected, and also, you know, whoever found whatever way convenient started storing the data in that way. For example, some naive people who were, not into databases and all, would store their data in Excel files or even in Word files. Okay. So how do you mine that data? It is very difficult, right? Now, even if the data was in the database format, okay, so that database could have been a very long, outdated database which we don't use today. That database might have used data structures which were, let's say, not even tables, that are normal relational database management systems, for example, Oracle and all use, right? So it is very difficult to consolidate the data that comes from such a large number of sources. Okay. And so we need to meaningfully, uh, decipher what this data means to be able to put it all together. Okay. This is one of the things that we were discussing last time. And this generally sometimes also is known as data integration. Okay, data integration, when we fuse data from multiple sources, and may require data transformation, as you can see on the slide. Okay, so an example of data transformation may be that we are converting the data from a flat file to a .csv format or a Oracle database format, something like that. So these are all examples of data transformation. Okay. Now, what are the other examples? Why do I say that the data in the real world is dirty? We had said, you remember, the GIGO mode, garbage in, garbage out, right? So if the data that we are using to retrieve our patterns is itself garbled, then obviously we cannot certify the correctness of the information or the knowledge that we have got, right? So the entire thing comes to a big zero, right? Now, why is this data garbled? Another forms of having garbled data are when we have data which has noise in it. Okay, so what is noise? Noise is generally erroneous values. Okay, when the data has error in it. Okay, another form of dirty data is we call the data dirty when it has missing values in the fields which we wish to otherwise mine. Okay, so how would you know make interpretations? How would you draw out patterns from the data which is not even complete, right? So these are some of the things that come under data cleaning in the pre-processing step. Is this clear? So to recapitulate once again, we had said that the process of data mining falls under the bigger process of knowledge discovery in databases, which in itself can be partitioned into three parts: the data pre-processing, data mining, and data post-processing. Is that clear?
Yes, ma'am.
Yes,
Excuse,
ma'am.
Right. So,
excuse me.
yes.
Ma'am, can you repeat this last paragraph?
Yeah. So, if you remember, we had said that KDD is actually the process of knowledge discovery in databases, can be broadly, very broadly seen as three basic steps: data pre processing, wherein we prepare the data for mining, then the actual data mining step, where we apply one or more data mining techniques. Okay, we apply the actual algorithms to discover the knowledge, and then this knowledge still undergoes further post processing in the form of certain visualization or integration into the decision support systems to finally give us the knowledge or the information that satisfies certain criteria. Is this clear? Okay, so I had uh, already in the last class said that in various research papers and in various books you'd find this process of KDD depicted a bit differently. Okay, another slide to show you the same KDD process I've put in this presentation, therefore, to give you another perspective. So here you can see that these three steps: selection, data selection. We had talked about data selection also last time, if you remember. Data selection could be done horizontally as well as vertically, right? Followed by, generally data cleaning, then data integration, data transformation. So these are some basic core steps which are involved in pre-processing. Okay, but this diagram shows them separately. So they've shown pre-processing as a different step, data selection as a different step, data transformation as a different step, but otherwise all this uh, you know uh, part of the this entire sub process, as we can call, can be collectively called as data pre-processing only. So generally data selection, data cleaning, data integration, data transformation, they're all considered to be a part of data pre-processing. So I had shown you these two perspectives of the KDD process. Okay, you may pick up more books or research papers, and you may still find other, you know, diagrams depicting which may be a little different. Okay, but that's okay. The idea is that you should understand how the process works. So this is the pre-processing step. Okay, this is the pre-processing step, then the data mining, and then the post-processing step, which is depicted here. Is this clear to everybody now?
Yes, ma'am.
Yes, ma'am.
Right.
Yes, ma'am.
Yeah. So let us just go through these slides once again, although I've covered most of these things. So who will read this slide for me?
Ma'am, may I?
Yes, yes, please. Yeah.
The steps involved in data processing includes fusing data from multiple sources, cleaning data to remove noise and duplicate observations, selecting records and features that are relevant to the data mining task at hand.
Is this
Most
clear to everybody? Is this thing now clear to everybody?
Yes, ma'am.
Right.
Yes, ma'am,
Yeah.
it is.
Yeah. Please continue.
most laborious and time consuming step.
So data pre-processing is one of the most laborious and time-consuming step. So you will find that uh, this is the case when you do actual practicals for, removing noise from the data. We will be defining what is noise precisely. Okay, so what is noise? Removing noise, removing missing values from the data. So all these things we will be devoting our attention to in the next chapter, that is the data pre-processing. And then there are certain practicals based on that you will be doing. So you will really see for yourself that this is sometimes even more laborious or more time consuming job than the actual job of data mining itself. Okay, yeah, yeah,
Also called
please.
as
Now, this is
also
data. Now we are going to talk about data post processing. Okay, I have already given you the idea. Let us just, formally read through the slides, and I'll keep on explaining side by side. Yeah.
also called as closing the loop to refer to the process of integrating data mining results into decision support system. For
So this
example,
process is known as the process of post processing, is sometimes also known as closing the loop. That means we are closing the process. And how do we close the loop? By integrating the results or the patterns that we've got out of the data mining step. These are used in conjunction with certain already built systems. For example, there is an example here. Yeah, can you please read this example?
in business applications, the insight offered by data mining results can be integrated with
Campaign management tools.
campaign management tools so that effective marketing promotion can be conducted and tested.
So
Need
there
to
are already, yeah, just a sec. So there are already decision support systems such as campaign management tools, which allow a company to take decisions upon which campaigns should be launched for marketing. Okay, so for promotions. So to be able to use the data mining results, what we desire is that the results can be directly deployed into one of these tools. This is just one of the applications. This is just one of the applications. First of all, please understand that, you know, uh, A campaign management tool is one of the applications. There can be many such other decision support systems and different applications which may be there. So it is desirable that the results which are delivered from the data mining step are directly integrable. They're directly, you know, fusible with the campaign management tools, or these decision support systems, so that they can take their decisions based upon these outputs. Okay, this is what we are talking here, and this is what is referred to as closing the loop. Okay, yeah.
Need to ensure that only valid and useful results are incorporated into the decision support system results.
So you remember we had said that information is not knowledge. Information must satisfy some criteria for it to be termed as knowledge. Okay, so you can see that a similar thing is what we are saying out here. So I had listed down some criteria for you, for example, novelty, interestingness, actionability, right? So here again, they are talking about two criteria that must be satisfied by the results which we have got out of the data mining step, so that these results can be deployed in the decision support systems. Okay, and these criteria are that these results should be valid and possibly usable, right? Yeah.
Statistical measures or hypothesis testing methods
Statistical
can
measures, yeah, statistical measures or hypothesis testing methods. Hmm.
can also be applied during post processing to eliminate spurious data mining.
So this is again a task which is done at the post processing stage. What is this task? This task is to eliminate uh, there may be, when you do the actual data mining tasks in lab, then you will see that sometimes we get, for example, we may be getting some rules, many of which may be saying the similar thing. Okay, so it is not desirable to put all of these into a system. Okay, so what do? We would like to only retain the rules which are unique, right? So how to remove all these spurious results? One of the way to do is to do this is by using existing statistical methods. Okay, yeah. Next.
Another example of post processing is visualization, of which allows analysts to explore the data and the data mining results from a variety of viewpoints.
So this is another task. So we have seen three tasks actually, you know, an example of three kinds of tasks which are done during post processing. The first is that you've seen that the results are integrated into the decision support system. The next is that statistical methods are used to eliminate duplicate results. And the third one is the visualization. So sometimes special softwares are made just to visualize the results which are delivered by a data mining algorithm. So these results may help you to visualize the patterns in graphical forms, for example, by drawing out, pie charts or graphs or some things like this. Okay, so that it is because the data that we have mined is large, the results may also be large. So individually analyzing them, textually analyzing them may be very difficult. Okay, so softwares are made, which are known as visualization softwares, which help the which help us to see, which help us to comprehend, that is, understand the results which are drawn out of our data mining systems. Okay, so even R that you are going to use in the practical lab, okay, it has some features plot the results that we get. So you can plot some graphs in R. Okay, so that is also something which is there in R. But so apart from R, sophisticated pure visualization softwares can also be built. They are also built actually. Okay, so that senior management could just see the charts and graphs, and they can take their decisions. Okay, this is another thing that is a part of the post processing step and not technically the data mining step. Is this clear? Is this clear to everybody?
Yes,
Yes.
ma'am.
Yes, ma'am.
Yeah. Okay. The next thing that we are going to discuss is what is data mining and what is not data mining. So, in a sense, what we are going to be looking at is that we are going to perfect our understanding of, what kind of things lie in the domain of databases and where does data mining start. So, although I have already given you a base on this in the very first class itself, okay, where I told you that wherever explicit information is stored and retrieved, that is largely a domain of the database systems. Okay, where we try and retrieve implicit, that is hidden information, that is where we start talking about data mining. That means we don't even know ourselves sometimes that what are we going to get. Okay, so we devise the algorithms, we devise the data mining algorithms and run them blindly. Okay, we run them blindly, and uh, whatever the results then we get, we try and make sense of them in the post processing phase sometimes. Okay, now is it a good thing? Well, yes, because this helps us, give us information which is novel, which may even be surprising. Okay, so let me give you an example of a surprising, pattern that was revealed. So there was in US there was a small grocery store uh, near a construction site. Okay, so there were some laborers which were working in the construction site, and what happened? Every Friday for merrymaking, they would to spend their weekend. They would go to the grocery store and they would pick up, beer. Okay, so they would buy beer, right? When the database of this grocery store was mined, a pattern that came forward was that the sale of the sale of beer led to the sale of diapers, baby diapers. Okay, so this was a very surprising result. Okay? And in fact, people actually, dismissed this result, saying that यार ये किस तरह का रिजल्ट है, आई मीन ये थोड़ी कोई बात है, ये तो बेकार, आई मीन इसका कोई मतलब नहीं, कोई रेलेवेंस नहीं है. But then they actually observed that what happened was that on weekdays when the laborers, went to buy beer, to appease their women at home who were sitting at home and may, nag them over the weekend. They tended to buy some household item. Now, since coincidentally the diapers were placed adjacent to the beer in that particular mall, you know, they just picked up the diapers and walked home. Okay. So, they did not want to come forward as husbands who just, you know, indulged in merrymaking, but they were also carrying something for their homes. Is this clear? Right. So, this is one of the very amusing results, which was also, surprising, and will tell you that we don't actually know what kind of patterns will come out of a data mining system. But then, this also laid down the groundwork. This kind of a pattern also laid down the groundwork. It also placed emphasis on what items should be placed with the other items. Okay, so people started thinking more about the shelf placement. That means which items to place with other items. So if let's say item X is one of the best sellers, then you place a maybe a relatively new item which is to be introduced into the market along with that item, so that whenever a person goes to purchase X, his uh, eye also falls on that item, new item Y. Is this clear?
Yes, ma'am.
Right.
Yes,
Okay.
ma'am.
Yeah. So can you please read this?
What is not data mining? Look up phone number in phone directory. Second, query a web search engine for information about Amazon. Now,
Yeah,
what is
yeah.
data?
Please read the first point of this and this together. Yeah.
What is not data mining? Look up phone number in directory. What is data mining? Certain names are more prevalent in certain US location. O'Brien or Rourke or Rely
O'Reilly
in
in the Boston area.
O'Reilly in
So,
Boston area.
so please see what is not data mining? Simple searching of data. For example, looking up a phone number or a name, or, you know, as we said, searching for explicit information is not data mining. Okay. However, on the same data, if we were to, uncover certain patterns, okay, for example, what from the phone directory itself, that what are the uh, you know family names which have been residing in this area for a long time, then uh, then data mining would come into play. Okay. Yeah. The next one.
Second, query a web search engine for information about Amazon.
So
What
this
is
is a direct search, right? Huh. Next.
what is data mining? Group together similar documents returned by search engine according to their context. Example Amazon rainforest amazon.com.
So again, the same data, we are taking two examples. So if we are directly searching about Amazon, explicitly we are searching about Amazon, then whatever results come. This is not data mining. This is a simple database search, right? However, suppose Google gives us certain results. Okay, the Google is giving us certain results. Now we group these results automatically. Okay, this is again a data mining technique, grouping things together. This is known as clustering. Okay, so grouping things together based upon their similarities. So automatically the results which are retrieved may be clustered together into different groups. They may be segmented into different groups. So let's say the uh, first and the fifth and the sixth document which is returned by Google is placed into group 1, and the second, third, and fourth document is placed in group 2, and so on so forth. Okay, based upon the similarity of content in these documents. Okay, automatically, if this is done, then this is data mining. Okay, then this is data mining. Clear? This is one application of data mining that we are talking about. Is this clear to everybody? We will be talking more about clustering. I'm just giving you a very, very broad idea at this time. Is this clear?
Yes,
Yes,
ma'am.
ma'am.
Okay, good.
Ma'am, if we want to know what are the frequently contacted contacts in our phone directory, is that also data mining?
Yes, that can be up to some point, termed as data mining if it is not very simplistic. If we can simply do it through a SQL query, then why go to a data? Why would you install a data mining system? Why would you put a data mining system in place, devise new algorithms to get something that you could already do through the database systems? That is the point. Okay,
Okay, ma'am.
simple frequency count where you already know. For example, you already did, how much salary per department was there. So these totals and counts you were already doing through databases. Okay. But when the data becomes very high, okay. Now, for example, if we are talking about the frequency of items being sold, right? So there the transactions are coming, and we are mining them. We don't have an idea. We don't have any idea. Then a data mining system would come into play. Is this clear?
Yes, ma'am. Thank you, ma'am.
Yeah. Next is origins of data mining. Please read.
Origins of data mining. Draw ideas from machine learning, AI, pattern recognition, statistics, and database system. Second,
So data mining, works hand in hand with all these techniques. Okay. Now, so why do we say that? Why does the data mining have to work with statistics, AI, and all these machine learning and database systems? So we say that it does not have to work with all these related areas. It is advisable, it is beneficial for all these technologies to work with each other. Why? So that whatever is done in one particular field, for example, statistics and AI are, they have come much before data mining. Similarly, machine learning. It is data mining is a newer field as compared to machine learning. Okay, and as well as database systems. So the idea is that we should not be reinventing the wheel. Okay, we should try and utilize the techniques which have been already laid down in these fields. So these they have just shown these three or four, allied technologies or fields with which data mining is working hand in hand. Actually, there are more. For example, algorithms. So when we deal with algorithms and data structures, okay. So when we design data mining systems, we also have to think about, as I told you, we also have to sometimes think about new data structures. Okay. Or when we design new algorithms, we have to think about their complexity. Without doing that, we cannot proceed, right? So we have to think whether this particular problem is a NP hard problem or not. Are we proceeding towards a NP hard problem or not? Okay. Similarly, uh, statistics is known as a uh, theory rich, data poor field. Okay. It is known as a theory rich, data poor field. Why? Because how was statistics developed? Statisticians have laid down a lot of distributions, and uh, they have laid down a lot of methods. For example, how to lay down the hypothesis, then how to test the hypothesis, and then how to come to conclusion. So if you do a course on statistics, you will learn all this. Okay, just give me a second, please. Okay, so statistics is frequently known as a mm, theory rich field because a lot of work has been done to uh, you know classify the type of distributions. For example, a normal distribution, a zipf distribution, and this and that. So you know that if data follows a particular distribution, then these are the these are likely to be the characteristics of that data. Okay, so statistics has all that. But if you remember how the data for the statistics was collected, it was generally collected, they did not have much data to experiment on in those days. Okay, so what they did was they had to all your sensor data. How is that collected? The census data, for even they people even traveled from door to door collecting the census data in old times. Even today, certain census data are collected door to door. They did not have much data. But data mining, on the other hand, is termed as the data rich, theory poor field. Why? Because we are not interested in developing all the theory that has been developed in statistics. What we do is we simply borrow all the knowledge that has been already developed in the field of statistics to look at the tests which are available. So we collect data, we have a lot of data, and we apply the knowledge that is there in the statistics. For example, uh, my data is following zipf law, let us say. So directly I can infer that if the statistics says that if your data follows zipf law, then this are the characteristics that the data will satisfy, or is likely to satisfy. Then I am able to infer all those results directly. Yeah. So that is why we say that data mining actually works in conjunction with all these fields, right? Database systems, obviously, we have been talking so much about the databases. There is a lot of overlap also, and that is why we are actually trying to, distinguish between data mining and database systems. Why? Because there is a overlap, right? There are gray areas. Okay. Machine learning, again, now you're also doing machine learning side by side. So you will see that there are many things that you will find common in data mining as well as in machine learning. Okay. Yeah.
Traditional techniques may be
Mhm.
unsuitable.
Excuse me, ma'am. Ma'am, we have a lab scheduled at this time.
You have a lab.
Yes, ma'am.
Okay, just let us read through this slide and then I'll leave you. Okay.
Sure,
Yeah.
ma'am.
Please continue.
Traditional, ma'am, maybe you changed.
Is it visible?
Yes, ma'am, it is visible.
Yeah.
Traditional techniques may be unsuitable due to enormity of data, high dimensionality of data, heterogeneous distributed nature of data.
So this we have already discussed. Yes, and we will also discuss this in the challenges. Uh, so where should I send you the attendance sheet then? If you can
Oh,
wait for
ma'am, on
I'll send you on the WhatsApp group then.
Okay, ma'am.
Or if you can wait, then
Ma'am, we can wait also.
okay, okay. I'll just send the attendance sheet.